In a previous video, I showed you how LEDs can produce electricity as solar cells. So using that big LED fixture, I'm going to use the strips that are on the fixture as a solar cell, and I'm going to wire one of the panels out of the four to act as a light. And using these and some cheap jumper wires, I powered up some of the LEDs, testing the voltage and testing how many LEDs, how much voltage would light up. So ideally, 12 volts will run 4 pairs of LEDs. I also noted that 4 pairs draws 0.085 amps. I marked it with a magic marker. This is a thick epoxy, so you don't get shocked while you're installing the bulbs. Okay, this is supposed to be an insulative strip, and so is this. So we have 3 conductors. I'm going to sever it with the razor blade because the copper is not really all that thick. You can see cutting through it right here. I'm not going to show the rest of this. I'll just show you the result, because I think you know what it looks like when someone solders something. Alright, here we have a meter. You don't need to purchase an expensive meter like this. You can get a $10 meter from Harbor Freight. Matter of fact, those leads are from Harbor Freight. Everything I use is readily available to anyone. I've cut across the conductor there and there, and I need to find out if I actually have severed it. So this meter is set to make a tone. You see that little speaker? It's a little focus, come on, focus. There we go, a little icon right there. It tells me that if I have continuity, that is, if electricity can flow, it will make a tone. So, there, 0 resistance. So let's take a look. And what we want to make sure that electricity cannot flow from this side to this side. First we touch together, make sure the meter's working. Then put it on one side, put it on the other, and we have no tone. And because they're diodes, they block electricity running one way, and they let flow the other way. So let's reverse the leads. No tone. Again, test. And we'll test to see if they're actually in contact with the conductive strip. There you go. Alright, I've got all of the connections, well, some severed here. Right there. That's paste flux. Flux cleans up a joint. This comes in a great big tube, great big syringe. So you put a little bit where you want to make your connections. Cleans it up, makes for a better joint. Which is terrible. Autofocus. There we go. So instead of cutting a 1/8 inch piece of wire, I'm going to try and just use a piece of solder to bridge this gap here and to bridge this gap here. And let's see how that goes. Alrighty, so I soldered across the conductors. Solder wants to bead, doesn't want to bridge. It's not as easy as I thought it would be. Looks like it got boogered, but I think that's actually a solid connection. So is this. Now there still is no connection between this band of copper and this band of copper. Now I'm getting lucky here because positive and the negative are marked. So let's a little autofocus. Let's hook this up and see if we get some light out of it. Whew, yeah, We sure do. Wow. Alrighty, first I'll tin the soldering iron, put a little dab right there on the conductor. Another dab on the conductor. Another dab on the conductor. Again. I'll start us off. And I'll do that for the rest of them. So there we go, soldered on nicely. And all my bridges made. So let's test this out. All right, let's test out the LED setup we have here. We got all our little solder points, 12-volt battery, and woo! Oh my goodness! Oh my gosh! That is fierce. Now I did not solder up these last few sets, because there's no positive trace on this side. There's a negative on that side, and it's just how it's wired. So I am not going to worry about that section right there. So there we have a 12-volt LED light, and in further videos I'll show you how to use it for further applications.